We can also consider sample sizes here for proportion estimates. So there, the margin of error in the confidence interval is z alpha over 2 sigma p hat, which is here. And remember, we'd use p hat there if we don't know p. So here's a picture of our sampling error, or margin of error. You've got your population proportion in the middle of the sampling distribution, and then you add z alpha over 2 sigma p hat and subtract it. So that formula then, if we solve it for n, we get z alpha over 2 squared p1 minus p over sampling error squared, or use p hat here if you don't know p. So now a more conservative estimate of n can be found using p equals 0.5, and that's when you know nothing about the value of p. So you don't have a p hat. So if that's the case, then use p equals 0.5. So let's look at an example, put this to use here. So we have an anonymous survey, and in that survey, 22 of 50 college students admitted that they had cheated at least once. We wish to estimate the true population percent or proportion of college students who cheated at least once to within 2% using a 95% confidence interval. How large does the sample need to be? So we've got a sample proportion, 22 out of 50. So our p hat here is 22 out of 50, which is 0.44. And we're estimating within 2%. So our sampling error is going to be 0.02. And then using 95% confidence interval, so 95% confidence right here, our z alpha over 2 is 1.96. So this is the same table I used in the previous example. So now let's go ahead and grab our sample size formula. So then n is going to be the 1.96 squared, and then times p hat, which is 0.44, and then 1 minus p hat, so 1 minus 0.44 would be 0.56, and then divide by our sampling error squared, 0.02 squared. And if you enter this into the calculator, you will get 2366.4, and we always round those up, round sample sizes up, so 2367. So we need 2,367 in our sample in order to estimate the true percent of college students to within 0.02.